Let's go. So last time where we left off, we can visualize installed objects in the world, just like this kitchen tower. You can see it in the game screen. Also, if you hover your mouse pointer over it, name will be shown below in the status bar. What we're not yet showing is jobs that are meant to install an object at a certain location. So that's what we're going to do today. We're going to visualize jobs for installing objects. The first approach we'll take is what I would call the naive approach, and that's doing exactly what we did in the tile sprite manager. Allow the setObjectTexture function to also recolor sprites, and then loop over all the jobs in the world and show the ones that are of the install object type. So let's do that first. Let's go into a project. And one thing that I forgot to do last time is called the cleanup world function. So that means that objects that are deinstalled are never removed. I don't think we can deinstall just yet, but there's no reason not to add this function right now. So let's run and see if this still works as suspected. So we can still see the object right here. So that's nice. So let's work on visualizing the job. So the first thing we need is we need to recolor a sprite. And we can do that in the same way as all these other setObjectTexture functions. We are optionally allowing to pass in a color. If a color is passed in, we use that color. If it's not, we assume it should be white. And we do the same here. We take the color of white as default. And then in the redraw function, we can look through every job in the world.jobs. And then let's see. We can get a texture for the object on sprite. Oh, wait a sec. We are going through every job in the world. Then we need to do is we need to switch on the job.job call. And if it's an install object job, and only if it's one of these, then we can get a texture, and we can set the object texture for the object at the job.target position in the scene using a color. And this we will create a color called the sort of greenish hue. So we pass in calibrated red, green, blue, and an alpha value of 0.5, so it becomes translucent. And also let's go into our world and create an example job. So let's go back down to where we create our example world. So let's create a job. We'll create an install object job for the object at I think -4 by -2 is on the bottom left. And then we take our new world and we have our jobs and we enqueue this new job. Let's see if this works. Okay, switch needs to be exhaustive. That's true. So if in all other cases we don't do anything, just play. So let's run. So let's see. So we see our. That wasn't exactly what I was expecting. So let's go back to our world. And let's see. So, we're also installing the object on the same location. Well, let's take the installed object and put it right at the center. Let's see. So this one is now here, but we don't see the kitchen counter as a job right here. So what's going on? Well, the problem is that as soon as this job is enqueued into the world, at the next update, an idle entity will pick up the job. And once it's picked up on the job, it's removed from the jobs queue here and added to the job stack of the entity. And we can't see that right now because we're only looking at jobs in the world. So how can we fix that? Well, what we should have is a sort of all jobs property that shows all the jobs in the, not just in directly in the world, but also the ones that are picked up by entities in the world. So we're going to create this property and we will write a test to validate its correct functioning. So let's go into our world test and let's create a new test. We call it test world all jobs. This requires a world and an entity. And let's give it a name. Test entity and location. And the world entities will have this entity. World entities equals entity. Then we need some example jobs. So let's create the job number 1. We create a job with the job goal of change the tile for the target position, and we'll choose a specific one that is different from the other test jobs just to be able to easily differentiate between them. So we have this one, and let's give the build time 2. Let's get a second job, but this time use a different position. That way we can quickly see which of the two jobs are where, or whether they are both inside of the all jobs property. So let's enqueue the first job in the world. And let's put the other one on the stack of the entity. Now let's start asserting something. So let's assert that world.jobs contains target position equals a vector. And let's see, x3 and I2. So we should find the first job in the jobs queue of the world. We should not find the second job, so that's the one that has 5, 6 as a position. We're basically using now the positions just to differentiate. And we should find the world the entity jobs should contains target position equals a vector of 5 by 6, because this is the job that we pushed on the entities job stack. And then we should be able to assert some things about the all jobs property. So we take our world all jobs dot count equals 2. And this will give an error because we haven't implemented all jobs yet. So let's go into our world and let's see. Let's create one here. So we create a variable called all jobs of type an array of jobs. And for now, we will return just the jobs. we already have. So we assume allJobs has 2. Also, let's test a bit more. Let's assert that a world.allJobs that contains where the first job is, and it should also contain the second job. Now let's see if we can run this test. Where is my test? Let's see, am I not allowed to get the queue directly into an array? It's building now. Well, let's see, what is the, is it complaining about? Oh, this should be a double equal. So the test runs, but some of the assertions fail. So allJobs only contains one. Well, we expect 2. We expect both jobs, and the second job can't be found. And that's because our world only just has the jobs in it, not the ones from the entity set. So let's work on this a bit. So instead of directly returning this array, let's create a results array, and we populate it with the jobs. And then for the entity and entities, we append the contents of entity.jobs. So we add all the jobs that are picked up by entities, and then we return the result. So if we run our test again, this test now passes. So that's the all jobs property seems to work correctly. Now we can start using this new property, and we'll first do it in the object sprite manager. So instead of world.jobs, we'll do world.allJobs. So let's run. It should now see the job, and it stays, and you can see it now being, even if it's picked up. Also, we can do the same in the tile sprite manager. So this way we can also see tile jobs that are already picked up. Won't see any difference just yet, but it's not really a big problem. What I also want to show is how actually performing the job works. So we already have an object. Now the job never gets finished because there's not a kitchen counter item available in the world that the entities can pick up. So if I say we have our new world and we have our items, for instance, on location left, we'll create an item stack for object item. Let's put 2 there and let's run. Now you can see that something gets picked up, it gets installed, and we can see that it's actually the job is gone now, and it's now an installed object. So let's do that again. Let's run it again. Zoom in a bit. Oh, you can see it working on it, and finally installing it. So this is working correctly, and we can see that there are still a boxing kitchen counter available here. Cool. So I think this is it for this episode. Next time we'll start working on objects as workstations. So an object will be something that an entity can work on, for instance, to create new items to craft, so to speak. So, and we will do that by making it possible for objects to create jobs, and then those jobs can be picked up and can be performed by entities. So thanks for watching and have a good day.